Hello everyone, welcome to our first tutorial of flood suspectibility mapping. Today we discuss about the calculation of the single indexes. So first index is the topographic wetness index TWI. Basically the topographic wetness index is a numerical measures of the water availability or saturation in a landscape based on the topography of the terrain. So it is widely used in the various disciplines to understand the distribution of water across a landscape and its impact on various ecological and hydrological process. So range is the very important. TWI range varies with depending upon the input data. Okay, this have a not a valid range. The higher the TWI means the wetter region or more saturated, and lower the TWI indicates the drier region. Now, what is the formula of TWI? TWI equals to the ln or log normal A by tan B. So here A indicates the flow accumulation, scaled flow accumulation, and tan B indicates the slope, upslope. Now, why we consider the topographic wetness index as a indicator of flood? Topographic wetness index is often considered as a flood indicator because it provides an estimate how much water can be retained in the soil and how easily it move across the landscape. So let's start. Go to the ArcGIS and first add the dim. Okay. Now Now the first step is adding the dim. Here I add a digital elevation model. Now the first step is a fill. Just add the digital elevation model and the name is fill dim. Okay. Okay, our fill dim is ready. Now second step is calculate the flow direction. Just add the fill dim and name it flow direction and okay. Now we calculate the flow accumulation value. Just double click on it, and here flow accumulation means add the flow direction raster and change the path flow accumulation one. I name it. Now just okay. Now our flow accumulation value is ready. Now just calculate the slope, your spatial analysis, surface and slope. Here you can see the slope. Just add the fill dim and slope fill. Okay, okay, our slope map is ready. Now we need to convert this slope in degrees to radians. Okay, so for the conversion we just follow this formula. Here I write this formula, just check it. This is the radians of slope, degree into 1.570796 by 90. So just copy this formula. Okay, I copy this formula, and now just go to the raster calculator. Here you can find the raster calculator, map algebra and raster calculator. Now just paste the formula. Okay, and here the degree, just remove the degree and add the slope. Okay, now our final formula is ready. Just check the output raster name is slope radians. Okay, now just click OK. Now our slope radians is calculated. Next step, the next step is here. Now our radians of slope is calculated. Now the next step is tan slope. Okay, the formula for tan slope, just copy this formula. Okay, now go to the ArcGIS and again the raster calculator. So tan slope equals to condition. Here we take a condition, and conditions and slope radians greater than equal to 0. Okay, and another is a and tan slope and comma 0.001. So just go to the ArcGIS. Here just scroll down and you can see the tan. Okay, tan, and add the slope radians and comma 0.001. Now its name is tan slope. Just change the name into tan slope. Okay, just click OK. Okay, our tan slope is calculated now. Now we just calculate the scaled flow accumulation value. So that's purpose. Just go at first we need to go our dim value, field dim. Just right click and go to the properties. Here you can see the source data. just copy this cell size. Okay, I copy this cell size, and now just go to the raster calculator, and the scaled flow accumulation formula is here. I write this formula in this sheet. You can see this flow accumulation scaled equal to flow accumulation plus 1 into cell size. Now just your flow accumulation plus 1, okay, is bracketed, just add the bracket, into into cell size. Just paste the cell size, okay, and its name is flow accumulation scale. Just click OK. Okay, now our flow accumulation scale is calculated. Now the final formula is need to calculate it. Just go to the raster calculator, and our final formula, just see this here. I write it. The final formula TWI equal to ln, means the log normal, flow accumulation scaled by tan slope. Okay, so just go to the TWI equals to ln. Here you can see the ln. Just this is a ln, and now flow accumulation scaled by the tan slope, and this is the final, which name as TWI, topographic wetness index. Okay, just click OK. Okay, now just change the grayscale. Okay, I scale. Now you can see this blue color, which means where the landform is well saturated, means the water retention is high, and this is the mountainous area. That's why the TWI is the low. Okay, at first I just off this all variable and just open this TWI. I can better understood you what is the TWI. Okay. Now I can zoom this area. This area is a riverine area. That's why the soil moisture is a high. Okay, and this area is a mountainous area. That's why the soil moisture index is a low, or the soil moisture value is a low. Now you can see this linear river. This also river. Okay, this is a river, and this is a river. That's why the riverine landscape more susceptible for the flood. Okay, that's why we use the TWI as a flood indicator. If we change this color into this, okay, this greenery area is a high, and you can see the linear river. I just open the base map. You can better understand the diagram. Now uh, now you can see the green area, which is the main river area, which is more saturated. And the green area, you can see this, all the green area is the river. Okay, and the upper area, this is not saturated, this is the mountainous area, that's why the area is not saturated. Okay, now thank you for this video. In the next video I will show how to calculate the other single indexes of the flood susceptibility mapping. Okay, stay with us.